In this video, we'll see an example calculating present value for an annuity. How much should Emma pay for an annuity that would give her $5,000 at the end of every year for the first 7 years and $8,000 at the end of every year for the next 4 years, if the interest rate is 6% compounded semi-annually throughout the time period? First, let's draw a timeline. Emma will pay for an annuity now. As a return, she will receive $5,000 at the end of every year from year 1 to year 7, and $8,000 from year 8 to year 11. The interest rate is 6% compounded semi-annually for the whole time. The amount Emma paid for the annuity today is present value, which is unknown. At the end of the term, after 11 years of payout, there will be no more money left. Therefore, the future value is 0. There are 2 time segments here, the first 7 years and the last 4 years. Their PMT are different. We'll have to look at this question in 2 steps. Since FV is known and PV is unknown, we'll start from the second time segment. In step 1, we'll find present value PV1 for the second time segment. In the second step, when we look at the first 7 years, the PV1 becomes the future value for this time segment. We can then calculate PV2, which would be the price that Emma will pay for this annuity. In order to do the calculations, we'll need to identify the 7 variables for both of the steps: PY, CY, N, IY, PV, PMT, and FV. For step 1, the periodic payments of $8,000 was paid at the end of each year, so we'll set the calculator at the end mode. Also, PY is 1, PMT is $8,000. Interest rate is 6% compounded semi-annually. Therefore, IY is 6, CY is 2. Future value is 0. N is the total number of periodic payments, which can be calculated by numbers of years times PY. 4 years times 1 gives 4. Let's use the calculator to calculate PV. Turn it on. It is by default at the end mode. You would see BGN on the screen if it is at begin mode. Second on PY to enter, PY is 1 and CY is 2. Second quit. 4 for N, 6 for IY, 8,000 for PMT, and 0 for FV. Compute PV. It is 27663.81158. This means the $8,000 periodic payments for 4 years is equivalent to one payment of $27,663.81 at the beginning of year 8. This number is also the future value for the second step, representing the balance left at the end of the first 7 years. Let's make it positive and enter it as FV for the second step. In the second step, the periodic payments of $5,000 will be paid at the end of each year, so we will set the calculator at the end mode. Also, PY is 1 and the PMT is 5,000. Notice here PMT and FV both are positive, representing cash inflow for Emma. We would expect the calculated PV to be negative, representing the price Emma has to pay for the annuity. Interest rate is the same as the first step. IY is 6, CY is 2. N is the number of years times PY. Therefore, 7 years times 1 equals to 7. Let's use the calculator. PY, CY, and IY stay the same as the first step. We'll enter the new value for N, which is 7. PMT is 5,000. We have already entered FV. Compute PV. We get 46111.87866. Run this number. Emma should pay $46,111.88 for this annuity. Now we have solved the problem. Thank you for watching.